Hey, good morning, and welcome to the Riverwood Conservancy's newest webinar, Green and Resilient Homes. Thanks so much for joining us this morning. Hope you're doing well, staying safe. My name is Rashid Clark. I'm the marketing specialist at the Riverwood Conservancy. Thank you so much for joining us today, and thank you to Climate Impact for helping to make this webinar possible. A few housekeeping notes before we get underway. Here in Mississauga, we are in a lockdown. That does mean, however, that Riverwood is affected to a degree, but thankfully our parking lots are still open. Our trail network is still open, so you can still come to Riverwood and enjoy the park. And also our in-person programs are continuing for the time being with strict limits on group sizes. So they will be entirely outdoors, limited to 10 people, including staff and volunteers, and masks will be mandatory, and social distance as much as possible will take place on our in-person events, which we'll be carrying on. Of course, we'll be monitoring things from week to week. If the situation changes, we'll revise our plan for in-person events as well. And one last note before we get to our presenters today, we have recently released our nature gift guide on our website at theriverwoodconservancy.org. It's a great way to support our work so we can continue to do programs like this, as well as conserve all the wonderful environment that we have in the park. And it's a great way to spread some joy to the natural world this holiday season. Eco-friendly gifts. We're all about eco-friendly stuff today. That's why we're doing this presentation. We'll get to our presenters in a moment. Just one last note, if you have questions at any point throughout the presentation today, please type them into the Q&A tab here in Zoom, and we will get to your questions at the end of our presentations. And we will be seeing presentations from Stefan Magneron from Homesol, who is passionate about energy efficient, sustainable, and affordable construction and renovation. He's the lead energy consultant at Homesol and a certified energy advisor, and has evaluated over 3,000 new and existing homes for NRCan programs. Stefan is also qualified as a Green Rater and Quality Assurance Designate for LEED, L-E-E-D, homes and mid-rise buildings, and a certified passive house consultant. And Chelsea Dalton is an environmental activist, cycling advocate, and longtime resident of Mississauga. She earned her honors in a Bachelor of Science at the University of Toronto Mississauga in 2007 and began working at UTM shortly thereafter. She currently works as the Acting Sustainability Manager, Strategic Initiatives in the Department of Facilities Management and Planning. Chelsea is a lifelong environmentalist, member of the Riverwood Conservancy's Stewardship Committee, and a citizen member of the City of Mississauga's Environmental Action Committee. So Stefan, I will first of all turn things over to you.
All right, well, thank you very much, Rashid, and good morning, everyone. As Rashid said, my name is Stefan Magneron. I work for Homesol Building Solutions in the Perth, Ottawa area, and we call ourselves energy conservation consultants. So we help homeowners and builders and architects design and build their homes to higher standards, but also to building code to meet the demands of the specific project. And so in this talk, I'll give you a little bit of guidance on how one can get started on the path to energy efficiency, to higher building standard, and what some key things that you need to think of as you move forward and as you go through the process. The first thing that I would always recommend is that you align yourself with an energy consultant. And one good place to look for energy consultants is the CASE website. That's the Canadian Association of Consulting Energy Advisors. And you can find a local energy advisor to your area who can help guide you through your process. If you're in an existing home, then likely they would have to come in and do a home evaluation, which would include a lot of data collection of the current state of your home and all the equipment and insulation levels. They would then perform a blower door test to see how airtight your home is. And then they would put that into the energy model and then recommend upgrades. So you'll be able to see how much of an impact those upgrades will have on your particular home. So it's very customized. When we as energy advisors make recommendations, we always keep the house as a system ideology in mind, meaning that there's not one single component that can be upgraded that will do everything that you want. It's really, you have to think of the house, the thermal enclosure, as well as the mechanicals and the air tightness and the occupants, how you behave in the house, which is very different to your neighbor who could be in the same type of house, exactly the same house, but they just run their household much more differently. And so this house as a system idea revolves around three main things. And as we move to the Christmas season, it's all about HAM. And HAM stands for heat, air, and moisture. And so if you can control or at least modify those three elements in the house, then you're well on your way to a more comfortable house, with the side benefit that you get some energy efficiency and lower bills. And so what do I mean by that? Well, let's go through them. With heat, obviously the first thing that comes to mind is insulation. And if you're talking about an existing house, what type of insulation do you have now? What do you plan on doing in the near future? And how much insulation can we add to it? So that's one area where heat can be impacted. Windows as well. Windows is another key one. Obviously, they let in a lot of light, which if it's direct sunlight, then that's direct heat gain. But then sometimes that could be a little bit too much, which we think that in Canada, we're in a heating dominated climate, and we don't think of overheating as being an issue. But as we add more insulation, make our houses more airtight, the unintended consequences are that with these higher solar heat gain coefficient windows, we end up with a little bit of overheating. So it's trying to strike that balance. And also, obviously, because they're glass, there is some heat transfer through the glass itself and through the window as a whole. And so we want to specify windows that will minimize that heat loss. The other important heat transfer, which also goes into the next one, which is air, is air tightness. And so I mentioned during a home evaluation, there would be a blower door test. And so that tests how airtight your house is. And in building science talk, we always say that you want to build it tight and ventilate it right. So the goal with air tightness for all homes and all buildings is for it to be 100% airtight. Now, that's not possible, but you want to get as close as possible, as close as feasibly possible. And there are many ways that air tightness can be achieved with a new or existing house. So that's something that your energy evaluator can certainly guide you and your contractor or builder. Then there's the ventilation side of that, build it tight and ventilate it right, because let me ask you this. How many holes do you want in your house? Now, I'm guessing most people will be saying, I don't want any holes in my house. And so you really want to make it airtight and then control what air comes in and what air goes out. And you do that with a heat recovery ventilator or a HRV or ERV. And so you concentrate all the air infiltration in through the ducts, and it goes in and out, and you don't get the penalty of heat loss because of the heat exchange that happens within the units. And then moisture, it sort of bridges all of the HAM elements, the heat, air, and moisture, because through air leaks, a lot of moisture is transferred from inside the house to outside or vice versa. So another great reason why you want to have your house as airtight as possible. And another reason to have the ventilation is so that you can properly ventilate and get exhaust as much of that stale, moist air out of the house so that it doesn't accumulate in the house, and then you have moisture related issues like, in the worst case scenario, there would be mold. or some building durability issues because of air leaks in random spots throughout the house. So moisture is another big one. And we always talk about having a house that breathes. Well, we don't want the house to necessarily breathe through the walls. We want to control that with the lungs of the house, which is essentially the ERV. So these are the things that we as energy advisors will sort of guide you through. We take the thermal enclosure approach first. So if we can upgrade that initially, then we start talking about, okay, well, we've already upgraded the ventilation system. Now let's look at the mechanicals. And the reason why we do it in that order is because if in a situation where you are in an existing house and you're upgrading it, if you're upgrading your mechanical system, your heating and cooling systems to what the house requires now, if you were to make the thermal enclosure upgrades, add more insulation, make your house more airtight, upgrade the windows, then all of a sudden your furnace or your heating system becomes oversized. And the problem with that is what we call short cycling, where the furnace will blast a lot of heat, which is great because it keeps us warm, but then it'll satisfy the thermostat really quickly, and then it'll shut off. And then what happens is that the house starts to cool down, or in the worst case scenario, the room in the furthest part of the house doesn't get enough heat. And so now you have a lot of stratification, a lot of temperature differences between the rooms in the house and different areas of the house. And that reduces the comfort of your house. So that's why we take the approach of doing the thermal enclosure first and then addressing the mechanicals afterwards. And so that's this process can be done either all at once if you happen to be doing a lot of renovations to the house to begin with, or you can stage it. And certainly with the guidance of the energy advisor and the project team, we can come up with a game plan on how, which steps to take when, depending on the circumstances. And so over the years, you have the final goal in mind, and then you can work towards it little by little. One thing that I would definitely say is that if you were in a situation where you would need to change your heating system or your air conditioning system, one of our big renovation recommendations is to upgrade the AC to an air source heat pump. Now, air source heat pumps have come a long way over the years, and now these days there are cold climate air source heat pumps that run at very efficient levels down to -30, -35. So you're almost guaranteed heat from these units. And if you do have your furnace still, then that can remain as a backup. But then you significantly reduce your energy usage and perhaps your energy bills as well. So the beauty with these air source heat pumps is they provide space heating, but they also provide space cooling. So as our climate warms, then space cooling becomes a big part of every house. So that's one of my recommendations as you were to move forward. And I think that's it for now, but if anyone has any questions, I'd be happy to answer them.
That's great. And yeah, you know what, we do have, pardon me, we do have a few questions that have come in already. So Stefan, I think we'll just get to a couple of them right now, if you don't mind. One
Sure.
For the, let's see, from our audience here today, in addition to thermal insulation, could you elaborate a little bit more on the importance of wind barriers and air barriers?
Yes, so air barriers are critical. Wind barriers are more of a redundant air barrier, but there is benefit. Wind barriers do increase the thermal efficiency of the insulation material, depending on where it goes. As far as an air barrier goes, its place, within a wall system, as an example, can be anywhere, as long as it is treated as an air barrier, and as long as its vapor permeance allows it to be placed anywhere. So for example, house wrap can be an air barrier. It can also be a weather resistive barrier or wind barrier. And it can be placed anywhere in the wall system because it allows vapor to diffuse through it. Vapor 6 mil poly, for example, can be an air barrier, but it's also a vapor barrier, which means that in our climate, it has to be on the warm side of the building assembly. It can't be on the outside because then you'll run into condensation issues.
Okay, and we'll get to one more question now, then we'll turn things over to Chelsea, and then we'll come back to a full Q&A segment right at the end. So one more question for you, Stefan, right now. If you decide to upgrade your household, windows, air, heating, etc., would you recover those costs through the newfound energy efficiency that you have?
Costs are a tricky one because historically, we in Canada have the lowest energy uses across the world. Natural gas is super cheap. Despite how we feel about hydro rates, it's pretty cheap compared to places like Europe. So from a payback point of view, we try and stay clear of that because the value that this kind of renovation brings is the comfort, the passive comfort that comes with that extra insulation and the air tightness and the better windows. It provides you with a more durable building and one that is also more resilient. So certainly as you get up to net zero levels of insulation and definitely passive house levels of insulation, if we were to have another ice storm like '98 and we're without power for 5 days or more, you likely would never reach the freezing point in a house like that. So there's that climate resilience in that sense.
Okay. And thanks for all the questions that are coming in from everyone watching. We will get to more of them at the end of Chelsea's presentation. But right now, I do want to turn things over to Chelsea, and I'll ask her to share her screen because I think she has some slides. Yeah, and we'll get to Chelsea's segment, and then we'll get back to the Q&A. So as Chelsea is going, if you have any questions, please drop them into the Q&A panel. And again, we'll get to those right at the end of Chelsea's segment, which will begin now.
Hi, everyone. So I'm here to give kind of the homeowner's perspective on green and resilient homes. So a little bit of background on me. Rashid obviously gave my bio, but I have lived in Mississauga since I think 1994. I think was when we moved to Mississauga. So I've lived here for quite a long time, and again, as Rashid mentioned, I am a lifelong environmentalist. So I'm kind of going to give the homeowner's perspective on how I kind of incorporated that environmental perspective into my home and the kind of stuff that I've done with my own home here in Mississauga. So the first thing that I kind of want to start with here is all energy and resource use has environmental impact. And this is kind of the guiding principle that I have used to inform the decisions that I've made in regards to not only how I retrofit my house, but also why I bought the house that I did. So it's important to remember, and someone will always say this to me, they'll say, but solar doesn't have any environmental impacts. Actually, it does. Solar panels are A, energy intensive to manufacture, and B, they do contain heavy metals and they require special disposal at the end of their life. So all energy and resource use does have environmental impacts. So the best kilowatt hour of energy is the one that you don't have to generate. And that's why I very much take like an efficiency first kind of perspective when I'm thinking about my home and I'm thinking about the retrofits and this sort of thing that I've been doing to my house. Another big thing to think about is the embodied energy that goes into the construction materials that are used in building. you know, having when you buy something, or when you build something, you're extracting raw materials, you're processing them, you're shipping them to the site. There's energy that goes into both manufacturing those materials, transporting those materials, and then actually using the end use of those materials and building the home. So there is a fair amount of embodied energy in that. Different materials will vary in different ways. Some of them have more embodied energy than others, but there's always embodied energy in the construction materials of the building. And so for that reason, I've always felt that kind of the greenest house is the one that is already standing. And for that reason, that is why I decided to buy an older home that was already here. Currently in my neighborhood, we are seeing a lot of people who are purchasing the houses that are here, tearing them down, and then rebuilding them. Which, first of all, I think is a real shame, because, you know, it's really changing the character of the neighborhood. And secondly, I just think that, you know, if you take the houses that are already standing and you upgrade them to be more energy efficient, I think you're really probably coming out ahead in terms of energy use and carbon footprint. And another thing that we did, that we, you know, decided upfront before we even bought the house that we're in now, was we didn't want to buy more house than we need. So it's just my husband and I, just the two of us in our family, plus 2 cats. So we didn't think that we wanted to buy a really big house. A lot of houses, particularly in Mississauga, can be like, you know, 4,000 or 5,000 square feet. We did not need that much space. So having a little bit of a smaller house means that there's less to heat and less to cool. So it's more efficient for us because we're just not heating a lot of space. We're not needing to cool a whole bunch of space. We're not having to light a whole bunch of space. And then the other bonus of this, of course, is that it's less to clean. We looked at some listing for houses that had, like, you know, 4 or 5 bathrooms. I don't know about anyone else. I don't like cleaning, and I don't want to have to clean that many bathrooms every week. So I like having the smaller house that I have, because it means that I have to spend less time cleaning it once a week. And then, of course, the big thing, what's the most important thing in real estate? Location, location, location. We looked at a couple different neighborhoods in Mississauga, and we wanted to choose a walkable neighborhood. Again, in Mississauga, this can be difficult because Mississauga's walkability is not great in some areas. The area that we are in, we actually looked for walkable neighborhoods first, and then we looked at the houses that were there. So we're located in Streetsville, which means that we are close walking distance to amenities, including restaurants, shopping, and public transit. I'm walking distance from a few different Mississauga transit stops, and I'm also walking distance from the Streetsville GO station, which is very convenient if I need to get into the city, like into Toronto. It's very, very easy for me to do so, because I can just walk down to the GO station and hop on either a GO train or a GO bus. Another big thing is that I do bike to work. You can see here in the photo on the left. That's me outside my house on my bike. This photo was taken in February 2019. This was winter bike to work day that year. So I find that with biking, we deliberately bought a house that was biking distance to work, because we knew that I wanted to continue to ride my bike to work. The place we were before, we were renting an apartment, which was biking distance to my work. And then when we bought a house, we made sure that we bought one that was biking distance to UTM where I work. Again, commuting is simple year-round, and I do commute year-round. Like I said, this is a photo that was actually taken on Winter Bike to Work Day 2019, and the vast majority of my winter bike ride days look like this. There might be snow on the ground, but the middle of the street, the pavement where I'm actually going to be riding, it's bone dry. And people always say, oh, but what do you do in the winter? You can't ride your bike in the winter. It's completely doable, and it really isn't a big deal. A lot of people kind of make it seem like you're some sort of superhero for riding your bike year-round, which, I mean, I admit, it's cool to have people thinking of you like a superhero, but it's really not a big deal. It's quite easy to do, particularly on days like this, and I'd say probably about 80% of my winter commute days are on dry pavement, just like this. But if I need to carry a bunch of stuff, or you know, I'm not feeling well, or if it is one of those rare days, probably 2 to 3 days a year, that are really too bad in terms of weather for me to bike, I can just hop on the bus. That works too. You know, it's easy for me to just walk to the bus stop and then hop on a bus to get to work as well. So because I bike to work pretty much every day. We only own one car, and this has actually helped us to cut down massively on our household expenses, which has helped us to finance some of the retrofits that I'm going to be talking about later in the presentation. So just a little bit of information about the house. So like I said, we're located in Streetsville. Our place was built in 1956, so it is a little bit of an older post-World War II kind of home. And again, with not purchasing more than we needed, as far as the house goes, it's about 1,200 square feet. So we find that that's a perfect size for the two of us. It is a bungalow, no basement, which is actually great. Wasn't something that I was necessarily looking for when we bought this place, but I think it'll work really well in terms of being able to stay in this house as we age, because we won't have issues with having to worry about stairs and that sort of thing. My next door neighbor actually bought his house when it was built, and he still lives in the same house. He's lived there since 1956. So that's really awesome that hopefully we'll be able to stay here as we age. It's 3 bedrooms, 1 bath. Again, for 2 people, that's all we need. And the people who live here are 2 humans, myself and my partner, and we also have 2 cats who live here with us. And one of them may decide to come up into the presentation. She really, really likes to jump up on my lap when I'm holding the Zoom meetings. So getting started, we bought the house, and as most people are when they first buy a place, we were kind of house poor when we first bought the place. So what we did was, the first thing we did was we focused on kind of the low cost, simple changes, the low hanging fruit, as they call it, that we could do that would be really easy to implement, again, low cost to implement, but that would give us some savings right off to start with. So when we first moved in, this house had not had like any upgrades or anything to make it more energy efficient. So we went through the house, and the first thing we noticed was that all of the light bulbs were incandescent bulbs. And we purchased this house in 2009. So we've been here for 11 years now. So the first thing we did was we changed all of the light bulbs and changed them out to compact fluorescent bulbs. We removed every single light bulb in the house, and then we went to the hardware store, we bought a whole whack of compact fluorescent bulbs, and we just replaced all of them, just a 1-for-1 change. Also, we noticed that when we had first been here for a couple weeks, particularly our TV room was a little bit cold in there. And we were like, oh, I wonder why it's so cold in this room. So we went to the window and we looked around the window, and we noticed that there were some cracks kind of between the window and the wall that were big enough that we could see daylight through. So again, back to the hardware store, bought a tube of caulking, sealed those up real quick, and it actually made a huge difference in the comfort of that room. People think that those small cracks won't really let a lot of air in or out, but when you add up all those small cracks, you realize that would be a hole the size of a football in my wall. So obviously that was something that we wanted to look after very quickly, and it made actually a big difference to the comfort of that room as well. We also put in a low flow shower head. The one that we had before was kind of your conventional high flow. So the low flow shower head saves water, first of all, because you're just using less water when you shower, but it also saves energy because it means you don't have to heat as much water unless you really love cold showers. I don't. So the low flow shower head has also saved us water and saved us energy as well. We also replaced the old thermostat that was in our house with a programmable thermostat so that we could have it turned down automatically at night, turned down automatically when we weren't home. The old thermostat was, it worked fine, but it wasn't programmable. And what was really interesting was when we took off that old thermostat, we actually could see the mercury switch in it. So we obviously, disposed of that properly as well. And then the photo on the left, that's my vegetable garden. And that was, again, one of the first things that we did. When we purchased this home, we specifically said that we wanted a smaller house, but that we did want a little bit of a nice yard for the house. And so we do have space out in the backyard to grow vegetables. I've grown vegetables here every year. Since we've lived here. And this is another thing that has a pretty low cost, particularly if you're starting vegetables from seed. But you save money on groceries, and like the vegetables that you grow in your own yard taste so much better than anything you could get from a grocery store. So we started the vegetable garden as well. We grow all sorts of different things: tomatoes, onions, squashes, peppers, you know, a whole bunch of different stuff we grow every year. It's something also that I really enjoy. I really enjoy growing vegetables. This year in particular, since we've all been home, it's been really great for me to be able to kind of just go out and do some weeding or some planting on my lunch hour when I'm at work. Unfortunately, this year I did have a groundhog who was living in my yard who got a lot of my tomatoes, but we got a motion activated sprinkler, and we have used that to you know, to kind of convince the groundhog to move to someone else's yard and stop eating all of my tomatoes. So some more steps that we took. When we first moved in, we did have the house inspected, and we were told that we needed to have our fireplace cleaned before we could use it. So we had the chimney sweep out, and the chimney sweep inspected it and found that our fireplace was actually not up to code, and that before we could use it safely, we needed to have some modifications to it. So we took that opportunity and we said, well, if we need to have the fireplace fixed anyway, why don't we get a fireplace insert? So how this works is this fireplace insert was inserted essentially right into the firebox of the old fireplace. It just works like a normal fireplace, except for that in the front of the fireplace right here, I hope you guys can see my mouse right here, there is a fan. And when we have a fire, the fan blows and it blows the heat out into the house. So normally you just have a fire and it would look pretty and it would be nice and, you know, it'd be warm when you're sitting next to the fire. But with this insert, when we have a fire, it actually helps to heat our house. And at the time we still had a natural gas furnace. So it was reducing the amount of natural gas that we need to use to heat the house. This also was particularly excellent. It doesn't work when the power is out because the fan is electric. You can see here's where the cord is for the fan to plug in. But this was really excellent the time that we came home from a weekend in Ottawa in January and discovered that our furnace had decided that it was going to quit on us. We did get it fixed within a couple of days, but you know, those first couple of days we couldn't get anyone to come out and fix it for us. So we were able to build a fire, get the fireplace insert going, and I think that by the time we went to bed that evening, it was about 21 degrees in here. So we were able to get up and keep up a comfortable temperature in the house, even when our furnace wasn't working, which was really fantastic. As I mentioned before, also my house is only one story, so with no second floor and no basement to heat, this pretty much heats our entire house. It's really excellent. So we also replaced the programmable thermostat that we had originally put in with a smart thermostat. First in Nest, and now I have, I believe it's called an Ecobee. So that's one of the ones that kind of automatically detects when you are and are not home and will adjust the temperature accordingly in your house. We also started doing upgrades. As I mentioned in the beginning of the presentation, we took out all the old incandescent bulbs and we replaced them with compact fluorescent light bulbs. Now we're at the point where LED technology is really good enough that it can replace pretty much all our bulbs in the house. So we have been, as the compact fluorescent bulbs have been burning out, we've been putting in LED light bulbs throughout the house. And these use a lot less energy. They're also really great because they have an extremely long lifespan. We haven't had to replace a single one yet. We also replaced our toilet with a dual flush model. So conventional toilets use approximately 13 liters of water per flush. Our dual flush toilet uses 3 liters for liquid waste and 6 liters for solid. And we haven't had, I know a lot of people are a little bit wary of dual flush toilets because they're worried that it won't work properly. We haven't had any issues. Ours has been completely fine. And then this year, it's not on the slide, but during the COVID situation and the toilet paper hoarding crisis, we actually purchased a bidet and put that on our toilet as well. I do get a lot of questions about whether or not a bidet is more eco-friendly than just using toilet paper, particularly because ours does have heated water, which is, you know, it feels a little bit like a luxury, but it is definitely a great feature if you want to have that. The manufacture of paper, toilet paper included, uses a lot of energy and a lot of water. So it is more environmentally friendly to use a bidet rather than toilet paper. So this is kind of the big project that we did to really kind of take our house to the next level, I felt, as far as energy efficiency goes. So we installed a ground source heat pump. You heard Stefan talk earlier about air source heat pumps. We actually went with ground source. So in the summer of, I believe it was 2017, our air conditioner died, which was not surprising. That air conditioner was definitely pretty old. It had kind of been on its last legs for a while, so we weren't particularly surprised when it died in the summer of 2007. And our furnace was starting to show its age. As I mentioned earlier, we kind of had that weekend where we went away and came back, and the furnace had decided to conk out while we were gone. We did get it working again that time, but we were starting to have a little bit of issues with it. And so it looked to us like we were probably going to have to replace both the air conditioner and the furnace. We decided to go instead with installing a ground source heat pump. People sometimes refer to these as geothermal systems. It is a bit of a misnomer, but sometimes people will also refer to geothermal, this type of system, as a geothermal system. So just a brief overview of how this works. We had 2 holes drilled in our front yard. You can see there, unfortunately the picture's like pretty dark, but that's actually the drilling rig that was parked in my front yard for a week. So we have 2 holes. There's pipes inserted in the holes, and we have an antifreeze solution that runs through those pipes. So how it works is in the summertime, the fluid runs through the pipes, and because the ground underground is about a constant 10 degrees Celsius year round, when you dig down deep enough, about 6 feet down, you'll find that it's about a constant 10 degrees Celsius year round. So the fluid runs through the pipes, it goes through the ground, and it cools down. The fluid cools down, rejects the heat to the ground, and then it gets pumped back into the house, and that cool fluid is used to cool down the house. In the wintertime, the process is essentially reversed. So the fluid runs through the pipes in the ground, it picks up heat, and then it comes back into the house, and it rejects that heat to the house, keeps the house nice and warm. So this was doable to retrofit into an existing home. A lot of newer buildings are made with geothermal or with ground source heat pumps. This was doable to retrofit into an existing home. It was more difficult because we don't have a basement, but it's certainly possible. I've had this system for I think about 3 years now, and it's been working great the entire time. My house is a pretty comfortable temperature year round. So this was also kind of the more expensive thing that we did. This was a little bit more expensive, and this was in 2017. So as far as this was at the point in time we were no longer house poor. We'd been getting larger salaries and that sort of thing. So this was something that we could afford at the time that we took it on. We did have to take out a loan to finance this. So in terms of cost, I know someone's going to ask about the cost. Ballpark cost was around $30,000 for this. Again, because I don't have a basement, it was more difficult not to bring its cost up a little bit. But we were able to pay it off within just a few years. It was paid off, I think, last winter. And if you keep in mind that when we did this project, I would have had to be replacing both my furnace and my air conditioner at the same time anyway. So, there was also that opportunity there where I said, well, I'm going to have to pay a little bit more to do ground source heat pump, but I'd be replacing my furnace and my air conditioner anyway. So that was how I kind of made that decision and said that if I wanted to do this, which I had wanted to for a while, this was going to be the way, the time to do it. So some future plans. We would love to get completely off of natural gas. Again, just for climate change related reasons. Ontario does at the moment have fairly low carbon electricity, which is why we've kind of been focusing on electrifying things. The ground source heat pump runs on electricity, just uses electricity to run the pumps. There's no natural gas involved in that. So how are we going to do that? We have 2 things that still use gas in our house. One is our barbecue. That's pretty simple. We just have to, we do have a natural gas barbecue. Again, that's pretty simple. We're just going to disconnect that and just have that line removed. And then the other thing that we have in our house that still uses natural gas is our water heater. We do have plans to upgrade that to an on-demand, sometimes called tankless system, which is also really good because it'll save us a little bit of space. Again, with a smaller house and with no basement, my water heater's in the laundry room, and if we get rid of that and put in a tankless system, it'll take up less space. So that's another benefit as well as just having a little bit more space in the laundry room. And I would also love to remove my front lawn and replace it with a natural meadow garden. My husband is less thrilled with this idea, so we're working on this. Removing the front lawn and replacing it with a natural garden might be something that comes a little bit later down the line, but we'll see. And the big dream, of course, is I would love to have rooftop solar. This photograph is actually from my work. This picture's from UTM. This is not a solar electric system in the photo. It's a solar thermal system, which heats water for showers at the athletic center at UTM. But I would love to have solar electric panels on my house, because then if I could run my house off of that, I'd basically be, the house would be, I think, pretty close to carbon free. The other advantage of having a bungalow is that I have a great deal of roof space. So I have a good amount of roof space for solar panels. I haven't yet looked at whether putting solar on my roof would be enough to kind of run the whole house, but that's definitely something to look into. This is renewable again, but it has a large price tag. So we're waiting a little bit to do this, just because it would be a fairly expensive thing to put in. And like I said, we're focusing on efficiency first, just because, as I said at the beginning of the presentation, the best kilowatt hour of electricity is the one that you don't have to generate. And I'm happy to answer any questions that you may have.
Very cool. Thank you so much, Chelsea. A wonderful presentation. And yes, we do have questions. Before we get to that, just a couple of points. First of all, don't be so bashful about cycling all year round, because I'm a real fair weather cyclist. So I will walk during the winter, but basically cycle during the summer.
Walking's great too. It's carbon free, right?
Walking's great too, but hats off to you for cycling even through the winter. And just a note on the bidets, yeah. Let's just say I highly recommend them as well.
They're awesome.
They are fantastic. And Stefan is now back, and we'll get to some questions. And I will just take this off the screen, or if you can. There we go. Perfect. Okay. And yeah, the questions are coming in. So thanks to everyone for tuning in and the discussion that we're going to have right now. So first question, and I guess this is kind of up for grabs between Chelsea and Stefan. Is there a lot of housing development in our area? I guess, meaning sort of the Mississauga, Peel region area. There's a lot of housing development happening. Are these houses built with green ideals in mind, and does Ontario mandate a level of energy efficiency? I don't know who's the better person to bring that question to.
I can speak to it to a certain degree. I don't know Mississauga super well, so I don't know which builders are there and to what level. What I do know is that the Ontario building code compared to the nation is pretty good. If anyone's heard of the BC step code, in BC, they're working towards being, especially Vancouver, being the greenest city in the world. And so they've developed this step code. It's a 5-step code, the fifth one being sort of passive house net zero. And we are sort of on the step 2 or 3, I forget which one. So we're halfway there as far as the BC step code compared to their base. So Ontario is pretty good. That's not to say that we don't have a lot of room for improvement. I think we have a long way to go still to developing a really climate resilient building code. But at least we're on our way. And there is a goal of, I believe the nationwide by 2030 or 2032, or maybe it's just Ontario, but all new homes will be built to the net zero ready standard. So there is a goal there. The Canadian Home Builders Association has a net zero program, and they're working towards getting builders on board voluntarily to build to this standard now, which is totally possible. We actually have also, I'm on the Net Zero Renovation Committee, and there are pilot projects coming out that these projects are renovating to the net zero standard. So that it's fantastic. In your area, I would look around and see who's building to at least Energy Star. I'm not familiar with anyone else in Mississauga specifically, if they're building to net zero or further. In the Peel region, I have heard of some custom home builders who build to the passive house standard, for example. So there are bits and pieces here and there, but on a whole, I can't comment.
Okay, well, we'll turn to the next question specifically for Chelsea. So when you were talking about the ground source heat pump, the only heat source in your home, is that enough? Does it keep your house comfortable?
Yep. So we have the ground source heat pump, and we also have the fireplace. We don't need the fireplace, really. Like I said, we got the fireplace insert when we were still using natural gas furnace, and now we know we have fires every now and then just because it's nice and cozy. But yeah, if I were to not use my fireplace, my house would be a comfortable temperature. Pretty much year round. Like I said, it does both the air conditioning and the heating. And I'm also one of those people who's like always cold all the time. So I certainly find it very comfortable in my house year round, even when it gets down to those really cold kind of minus 20, minus 30 days. It's still comfortable inside.
That's great to know.
Yeah, and that's the same. If you don't mind me jumping in, sorry,
Sure.
I was going to say that with ground source or air source, as long as they're sized correctly for the load of your house, they will be able to do it. With ground source heat pump, they're very custom to each project that they're installed in. With air source heat pumps, you can get air source heat pumps that can do commercial buildings. So it's available, it's out there, and it will go down to the cold temperatures that we experience. And then Chelsea, with your ground source heat pump, I believe, depending on how it was sized and what else you plan on doing to your house, you might be able to preheat your hot water with the ground source heat pump.
Oh, okay.
With the heater, and then you can move away from natural gas altogether. And then you would just need like a top-up electric resistance in the buffer tank. And then you can do your hot water with that ground source heat pump as well.
That's an excellent idea.
Yeah, there's technology coming. Some technology is available for air source heat pumps to be air to water heat pump. Right now, the typical air source heat pumps are air to air heat pumps. So the air to water heat pumps will allow these units to provide preheat for hot water as well. So yeah, the exciting technologies coming down the pipeline for sure.
I might email you after this presentation to get some ideas for the best way to replace my hot water tank.
Absolutely.
I was just going to say, that's terrific. Chelsea, you got some free consultation advice today as your reward for taking part in this presentation. Next question, I think probably sticking with Stefan for this one. Are there any brick paints or coatings that can prevent air loss?
No. I'm going to say for brick paints specifically, it's more of an aesthetic thing. What you want from your paint is at the bottom of the bricks, there are these holes in the mortar. They're called weeping holes. And so that allows, and then in the back of the brick, there's usually a 1-inch airspace. And so that allows for drying potential in behind that brick. And so you don't want that brick, the brick is just a facade, unless it's a triple brick home or like a load-bearing brick home. And so all that to say no. There are liquid applied membranes that are available that help with air, that are part of an air barrier strategy, but it would still need something to go on top of it. So for example, if one were to stucco a house, then there's a liquid applied membrane that's sort of like a house wrap, and it allows them to glue the foam onto the wall, and then they apply a finishing material on top of that. That could act like an air barrier, but on top of brick, you'd either have to go right on top of the brick or get rid of the brick altogether in that case.
Going back to Chelsea for a second, when you talk about all of the home improvements that you've made, how exactly did you approach this grand project? Did you talk to a consultant like Stefan, or just do your own research and go from there?
Yeah, it did. It took me actually a while to find a contractor, particularly because hydro prices are a little bit higher and natural gas prices are a little bit lower at this particular point in time. I had a lot of contractors who kind of said, well, there's no point in you putting in a ground source heat pump. because you have natural gas available to you in Mississauga. And it was like, well, no, that's not what I'm worried about. What I want is the environmental benefits of this. So it took me a little while. I just kind of emailed a few contractors, and then I had someone who came out and designed the system for us and looked after the installation as well. So I kind of did my own research. I didn't speak to an energy consultant or anything like that. However, because I work at the facilities department of a major university, I was able to speak to several of my colleagues there and kind of get some advice from them before fully committing to it. I should also mention that we have a building at UTM that uses ground source heat pump technology to heat and cool it as well. And because we built that building, I think in 2011, so it had been up for a while and running for a while, and I had seen how well that building had performed. We had some kind of like some old school facilities people there at the time who were like, oh, this new technology, it's not going to work. It's going to be a source of endless problems. We built that building, and it actually requires the least maintenance on campus. And the people in facilities now saying, oh, this building is so great because we have to spend so much less time there, and it works so well. So.
Back to Stefan for the next one. For the latest, or what are the latest developments in energy efficient windows, and how worthwhile are they, especially replacing a large glass window?
So windows have come a long way. Typically, for high performing windows, we look at triple glazed windows, which have been around for a long time, but because the standard here is double glazed, it's a little bit more expensive. But triple glaze allows for less heat transfer through the glass itself. It also requires the frame to be a little bit more robust, which increases its thermal efficiency, and so there's a lot more heat loss. And the beauty of that, it's not necessarily from the thermal from an energy efficiency point of view, but it's more from a thermal comfort. So especially with a large piece of glass, if you're sitting next to it on a cold winter's day, a really efficient window will have a higher interior surface temperature, which means that your body heat won't be lost to this colder surface temperature, which just happens naturally. Some people think that they have a draft near a window, but it's just because they have a poor performing window and that surface temperature is really cold. And so by having a high performance window, you reduce that thermal discomfort. Also, the technology in the e-coatings that can go on the glass will allow for the performance of the window to get better, but also you can dictate how much solar heat gain comes into the house, like I mentioned before. So for year-round comfort, you can specify a specific type of glass and you get almost 100% comfort. Cardinal Glass, they're a glass manufacturer, but they have a nice website where you can choose your glass specifications, and it shows how many hours of the year you'll experience discomfort. And I've managed to come across a combination where you get 0 hours of discomfort. So that's where glazing technology comes. And then if you're talking about large pieces of glass, obviously if the costs go up a little bit, but if it's a fixed piece of glass, then it's a lot more affordable than an operable window. So depends on what you have in the house.
If I could also chime in here, don't underestimate the power of the simple technology we have called curtains. It's actually surprising if you're using heavier, particularly if you're using like a heavier fabric curtain, that just opening and closing those curtains can actually make a pretty big difference in terms of comfort. I know like we have, a couple large windows in our house, and I always keep the curtains closed, particularly at night. During the day, I'll open them up, particularly if it's sunny out, to kind of let the sun come in and heat up the house a little bit. But particularly at night, there's a huge difference in just how comfortable it is sitting in the room with the curtains open versus sitting with the curtains closed. And I think you can even get curtains these days that have like an R value, have an insulation value. And that's something that would definitely be much lower cost than actually replacing a window.
Okay, we'll try to get to just a couple more questions as we're, closing in on the hour mark. And apologies to anyone who submitted a question that we couldn't get to today. One question, I guess, more for Chelsea, but I guess Stefan can weigh in on it as well. Rather than replacing all your light bulbs at once, considering that they probably have some embedded energy left to manufacture, would it not be more effective to just replace them with LEDs as the old incandescent bulbs die off?
So we did take a look at, so a lot of my background is in energy inventory, and I've done a little bit of life cycle analysis as well. We looked at it and we felt that it was more efficient to just pull out all of the incandescents and replace them with CFLs right away when we first moved in. Because the incandescents just use so much more than a CFL. The approach that we're taking now is, as the compact fluorescents that we put in are dying, we're replacing those with the LEDs because the difference in efficiency is relatively smaller. So that's the approach that we're taking with the move from CFLs to LEDs.
Question for, I guess, well, both of you, but I'll pose it first to Stefan. Would you recommend solar panels or geothermal for homeowners in Mississauga? And are there governmental incentives to upgrading your home to a green home?
So the question with solar panels or geothermal, it all depends. Unfortunately, that's the the standard. There's a lot into that. It requires a lot of research, just like Chelsea had done for her own house. I know for geothermal, well, let's look at solar for starters. Everyone uses electricity. So there is some benefit to putting in a solar PV array to start winding the bills backwards, so to speak. So if you're in the process of redoing your roof, then that's a great time. If it's going to be like, if your roof is going to need to get replaced soon, then I would hold off because you don't want to have to take all the panels down and redo it later. With geothermal, it depends on the cost. Right now, if you're in the Enbridge area, I know Enbridge has got this system now. I don't know if they've released it, but if they haven't, then it'll come soon, where they're providing geothermal. And I don't know all the details, but it's almost like a rental basis. So it really reduces the initial costs for the homeowner. But then you pay for it on a monthly basis. So there's that. As far as incentives go, the Liberal government during the last election had a $40,000 interest-free loan that they were going to release towards green renovations. That could be the installation or solar panels or geothermal. But then COVID hit, so that they had to pull back on that. I think it's still on the books. Whether or not they'll release it this coming spring, or we'll have to wait and see. But that's coming, and that will probably require an energy advisor to come in to evaluate your house first, and then after you perform all the upgrades to confirm everything was done. Enbridge also has another program. We're not involved with that right now, but it does incentivize insulation and windows and furnace upgrades. And so that's something that you could look into in your particular area.
And Chelsea, last question to you. Did you take advantage of any government incentives as you were going through the process of all of your renovations?
Yeah, unfortunately, we did not, because at the time there were no available government incentives. So unfortunately, we weren't able to take advantage of any incentive programs. So no, unfortunately we didn't, but I'm still glad we did it.
All right. And Stefan, last question for you. We're drumming up some business for you. Are you willing to work on projects in the Peel or Toronto area? And I guess what's the best way for people to get in touch with Homesol if they are interested?
Yeah, absolutely. As a consulting company, a lot of our work is theory-based until we have to go on site to do the air tightness testing and the inspections. So it depends on what kind of project you've got going on, but absolutely we can work globally, essentially, these days with technology like Zoom. And the best way to get in touch with us is through our website. That's Homesol Building Solutions. And that's the way to connect with us.
Okay, great. So Chelsea, Stefan, thank you so much for your time, and great presentations, great knowledge that you were able to share. And to everyone watching today, thanks for sharing your time with us and having such a nice little discussion for our presenters today. So again, Chelsea from UTM and Stefan from Homesol Building Solutions. That's HOMESOL Building Solutions.com for more information about the consulting services that they're able to provide. And thank you again to Climate Impact for their support of our programs and for making this webinar possible. You can learn more about Climate Impact at climateimpact.ca. And one last note on us, as we are continuing to offer in-person programs with safety protocols in place at Riverwood, please have a look at our website, theriverwoodconservancy.org, for more information on upcoming programs, both virtual and in person. And while you're on our website, have a look at our nature gift guide. Lots of great ideas to send eco-friendly green gifts to loved ones this holiday season, and you can do it in a very safe, socially distanced way. Thanks so much again for tuning in and joining us for our presentation today. Once again, thanks to our presenters, Chelsea and Stefan, for your time. And we will hope to see you again soon for our next webinar. And in the meantime, please take care and stay safe.
Thank you, everyone, for attending.
Thank you, everyone. Bye.